Welcome to another unit in this workbook statistics. This time I'm going to talk about Markov chains and how we can actually use the Markov transition matrices to calculate the steady state of a situation. In this regard, I illustrated the idea of a transition matrix graphically. Here we can imagine we have three different states a country could be situated in. It could be democracy, autocracy, or a dictatorship. And different countries switch between these, states, so to speak. So the chance of being an autocracy, remaining an autocracy, is 70%. 20% to become a dictatorship, 10% to become a democracy. If you are already a democracy, there's a 75% chance of remaining a democracy, 20% chance of becoming an autocracy, and only 5% of becoming a dictatorship. Those numbers at this moment are just made up. So I'm just going to illustrate the idea behind this. Well, finally we have the dictatorship, 60% of remaining a dictatorship, 20% of becoming a democracy, and 20% of becoming an autocracy. This can be written down in the form of a matrix. We have a 3 times 3 matrix, 3 because we have the 3 states. And let's say democracy is the first row and first column. So democracy to democracy, so from 1 to 1 would be 0.75. If this is the second, this is the third state, we would have in 1 to 2, the 0.2, we would have in 1 to 3 the 0.05. That's a way how we can construct the whole matrix, and this matrix is the so-called transition matrix or Markov transition matrix. Describes the chances to switch from one state to another state or to remain in said state. That's the main idea on constructing these transition matrices. Well, at this point, we just assumed that this is a one-time situation. This is how it happens. But if we consider this as a movement over time, development over time, then these chances, they might still remain the same, but we could ask a question in the long run. How many democracies, how many autocracies, and how many dictatorships will there be in the world? Also depending on what's the initial situation. The interesting aspect here is the initial situation we are going to start with doesn't matter because I will end up in exactly the same steady state no matter where I'm going to start. Well, so the question then more or less returns to what is this steady state, this long-term equilibrium situation like, and how can I determine this? Well, for this we're going to start with the transition matrix M, the one I introduced earlier. The one which has a row sum of 1 or 100%. Not something we automatically get if we use the information here. If I have 0.75 plus 0.2 plus 0.05, I'm going to end up with 1 or 100%. So the respective matrix already has a row sum of 1. So that's usually the easiest part. Then I'm going to transpose this transition matrix, and I'm going to subtract 1 from the diagonal elements of this transposed matrix. I could also imagine this as subtracting the unit matrix from this transposed matrix. Would be exactly the same. The result from this subtraction will be the matrix M asterisk. This matrix M asterisk I'm going to use in this type of a linear system of equations. So that's M asterisk times the vector of the solution shares equal to 0. So what we are actually calculating here is the kernel of this matrix. We then can determine the solutions to this system of equations. And well, the way we constructed the matrix M asterisk assures that this system of equations always has infinitely many solutions. So out of those infinitely many solutions, we're going to select the one solution where the sum of all the solution variables is equal to 1 or 100%. Then each of these solution variables gives us the share which each of the states will hold in the steady state in the long run equilibrium situation. So if we apply this procedure to this example displayed here and discussed in the slide before, what we will get is a situation with roughly 35.5% democracies, 40% autocracies, and roughly 24.5% dictatorships. There might still be changes even after we arrived at this situation, but we will keep those shares steady at a certain point in time, which usually is quite long off. And well, that's then everything there is regarding Markov chains, regarding the transition matrices, and how to calculate a steady state in this situation. So I hope you enjoyed this tutorial, and I say goodbye. See you next time.